effect of temperature on reaction rate. Increase of temperature increases the rate of the reaction. Usually, 10-degree increase in the temperature will result twice the rate of the reaction, approximately. And this can be mentioned as temperature coefficient. It means rate constant at T plus 10 degree Celsius divided by rate constant at T degree Celsius is equal to, that is, for example, let me consider rate constant, say about rate constant at 35 degrees Celsius. 10 degree rise in temperature means that is rate constant at 25 degree. That is the original one. So from 25 to 35, that is the difference in temperature. So this ratio is called temperature coefficient. They may ask, what is temperature coefficient? Usually this temperature coefficient may vary between 2 to 3. 2 to 3. Either it can be 2 times or 3 times. And usually the quantitative relation between K and T, relation between rate constant and temperature, is given by Arrhenius equation. Arrhenius equation. This can be given as K is equal to A exponential minus power minus EA by RT. This is a very important relation. This is called temperature dependence of rate constant, and that is nothing but Arrhenius equation, where A is constant, EA is energy of activation or activation energy, or universal gas constant, T temperature in Kelvin. E is the exponential term. T is temperature in Kelvin. You must remember this. It's not in degree Celsius. Now taking logarithm on both sides, you can bring this A towards left. So it becomes K by A, that is equal to E power minus EA by RT. So introducing logarithm on both sides, it becomes natural log K by A is equal to natural log of exponential term becomes exponential is cancelled. So it becomes minus EA by RT because they are inverse operations, exponent and logarithm. Okay. Now this log K, and you can apply the quotient rule. That is, quotient rule means what? Log K by A means log K minus log A. So log K minus natural log A. That is equal to minus EA divided by RT. Write down. And here you can bring this log A to the other side. So log K is equal to minus EA by RT in plus log A. Natural log A. These are all natural log. This Arrhenius equation is very important. So this is a logarithmic form of Arrhenius equation right now. Natural logarithmic form of Arrhenius equation. We are going to expand it further and convert it into log to the base 10 also. But before that, I would like to explain additional things here. Arrhenius equation is valuable because this can be used to calculate the minimum energy necessary to bring about the reaction between the two colliding molecules. That is called activation energy. If the experimental value of the rate constant is mentioned as K, and that is known. And diagrammatically, it can be represented like this is the reaction coordinate, that is reaction proceedings. And let me indicate the energy of activation. And this is the particle reactant A molecule and the B molecule. There are two reactants. They collide with each other and they get excited and they reaches the top. And after that, it comes down and probably it may come down even below the A plus B, that is reactant. It becomes product, that is C plus D is the product. Now you take this one and the wave height is called energy of activation. Now let me introduce another. When I increase the temperature, what happens? The same A plus B will, instead of traveling up to this, it will reduce here. And this is possible in the case of what? By introducing the catalyst also. So let us talk about that aspect later. But you must note down that this is energy of activation and this is energy simply. So this is the energy of activation, the wave height. There are so many aspects about this energy of activation. I will detail this as a separate aspect. Okay, so now I have clarified that effect of temperature on reaction rate. Okay, now let me explain about the energy of activation only, totally separately. Now let us take down the energy of activation. First point, for reactants to get converted into product, for reaction to convert into product, there is an energy barrier, right? See, you are studying now plus two, standard 12. You want to get into the higher level courses, and there is a barrier. They cannot take all the candidates. So there is a filtration process and there is an entrance examination. So you have to clear all these things, right? So there is an energy barrier, and it has to overcome, take down to overcome. We had to succeed that. It has to be overcome. And only those encounters in which the reactant molecules have sufficient energy to cross this barrier, they are declared pass. They become the products. Right? Okay, so those who are capable of overcoming this energy barrier can become the product. Okay, so this is about the energy of activation. For example, I was explaining about these energy of activation in a plot. So these A and B, they collide with each other. Some molecules they collide immediately, they come down. Some molecules they go on colliding each other. Some molecules they reach the maximum level. And after that, it crossed the energy barrier. It will come down to the other side. It means something like, just jumping over a castle. Okay, so that when you are climbing on the castle and you are able to see inside what is happening. Okay, ஒரு கோட்டைக்குள்ள போற மேலே ஏறுற முதல்ல ஏறுற ஏறுறது தான் கஷ்டம் ஒன்ஸ் ஏறிட்டோம்னா அந்த பக்கம் தப்புன்னு குதிச்சு என்ன வேணா பண்ணிக்கலாம். Likewise, so you have to overcome this, and once you are cleared that, then you are enjoying your premium institutions. Okay. Then, second point. Actually, this is a tremendous consequence to the existence of life. Actually, that is our life itself is consisting of lot of struggles. Okay. I used to say when there is no pain, there is no gain. So similarly, for even for the existence of life, we have to struggle, right? So such energy barrier, you can say, why such energy barriers? Remove that, then you cannot achieve anything. Okay. So you must encounter the obstacles you are facing. The otherwise, what will happen? All the fuels would have been consumed by the oxygen in the air. For example, you must have some what do you call some that is senses. You have to you must be able to sense the nerves, the feelings, the emotions, the stimulations around you. If you miss that, what happens? You are unable to react there. Okay, so we need to get excited. That is very important. Only thing is we should pass out that barrier. So in this case, suppose I apply some heat, means all the energy will be wasted in the oxygen only, that is as air, and nothing is taken inside, means totally waste. So the it is not possible on earth without the presence of these barriers. So existence of barrier is compulsory, no doubt. So this energy barrier, I was talking about this energy barrier, this is compulsory in life as well as in reaction. Third aspect about the energy of activation. Every action feasible from conservation of free energy need not necessarily take place. Every reaction feasible, possible reaction, you can feasible means possible. See, that is, it is not taken into account that all the efforts you are applying in your life cannot be taken as a guaranteed for the success in your life. Correct? Sometimes you may wonder, you are studying under my guidance and that too kinetics, and you just ask yourself, this bloody kinetics, in what way it is going to be helpful in my life? Nothing. But intangibly it helps. You have got the target and you have to achieve that. So that mentality is developed. Whether you crack the problem correctly or not, that is different. But your effort that is taken into stay, and it is not going to be wasted. Okay. So likewise, every feasible, so that is called actually, that is, I used to talk about this available form of energy and the non-available form of energy. For example, that is, we always talk about the important questions. On the eve of the examination, you used to ask me, sir, can you give me an important question? If I give you the important question, you will study only that important question and you can easily pass it. There is no issue about that. Why? Because it is the available form of energy and that which for which you are already prepared, so you can easily successfully come out. Okay, because you are exactly matched the energy required. So when you are asked to lift any table, will you calculate that how much energy is required to lift the table? No. So in that case, you know your presence of mind by applying your common sense. And sir, one person is very difficult to lift the table. Ask that guy so that both of us will lift the table. Agreed. The deal is over. Then you can take. Otherwise, what would I have been doing? Simply standing on one side. Can you lift the table? That is very difficult because orientation is also very. So you can just ask yourself to strike the egg, to break the egg. A hammer is required? No. You know very well. But in most of the cases, when I ask you to do some job, you guys, you take this as a huge elephant-like project and bring that hammer, what for you, to break the head, Is it a dinosaur's egg? No. So it's after all a small egg and we have to crack it. That can be done easily, effortlessly. So that we know the available form of energy and that much effort can be easily spent. So you come to the judgment. Okay. This is called available form of energy because you are aware of that one. That is called the Gibbs free energy, right? So what do you mean by Gibbs free energy? So we spend the enormous amount of energy without knowing the actual energy required for that job. So in that case, you are spending some amount of energy as a waste piece one. And the real energy should be taken, that is available form of energy. So when you carry out certain work, what happens here? You can classify your input into two ways. One is available form of energy, another is not at all necessary, non-available form of energy. So what is required here? Available form of energy. So that is why the chemical reactions are accompanied by the decrease in free energy. Please note on this one. So decrease in free energy. An increase in entropy. We used to say this is called D Downers advancement of a reaction. Yeah. You can simply put advancement of reaction. For the reaction naturally to occur, there are two important things. One is decrease in free energy. Second, increase in entropy. So that is the thermodynamic aspect. Entropy means what? Del S. Delta S means degree of randomness of gaseous molecules. Like in the case of a wandering dog in the street, as though it is going to achieve something, it will be wandering here and there. Likewise, our youth also. And this fellow one day will take cycle. He doesn't know where he goes, but he takes cycle, and finally he comes back. என்னடா எங்க போனேன் இல்ல என்ன போகணும்னு நினைச்சேன் சாகுக்காரன் பார்த்துட்டு வரலான்னு வாட் இஸ் திஸ் so without aim we are growing and coming. Okay, this kind of energy is associated, this tendency is associated with the almost all youths. But all youths are highly reactive because of their high entropy. And that is why you are able to do a lot of things in your world. So, in your young world, that is, you are capable of doing a lot of things. And that is why there are a lot of collisions. So, the collisions also increasing. When there is no more collision, there is more reaction. Why? There is more entropy. And that is why I said increase of entropy. Do you understand this? But at the same time, when you talk about that, free energy, decrease of it. So never forget these two. These two are essential. And I was explaining about this even when I was discussing electrochemical reactions, where I was explaining about the what is that? G is equal to delta G is equal to minus delta G is equal to NFE. Where I was explaining about the cell EMF. Usually the cell EMF should be positive on the day I was telling. Generally, you can claim that it is correct connection. Otherwise, if E is a negative means, oh, change the polarity. That's all. Okay. So you should, I hope now you can include that cell EMF also for progress of the reaction. Okay. Now, here I am explaining about the third aspect. That is every reaction, that is the concentration of free energy need not be necessarily taking place. Many be prevented by occurring by high activation energy barrier. So in that case, there is such reactants, though energetically unstable, but kinetically they are stable at ordinary temperature. So you can mention that reactants, take down reactants, energetically they are unstable. They attain some transition state. For example, these reactors they collide each other, they attain them highest energy level and where the stability is less. Higher the energy, less will be the stability. Take those. So at that point, when the energy is very high, it is highly unstable. So it has to take a call. How long you can be quarreling each other, fighting each other? Even let us consider two dogs. How long? Let us uh, keep waiting and watching the two dogs fighting each other. How long it will continue? Will it continue for 1 year? No. 1 month? No. 1 hour? No. It cannot. Within 10 minutes, everything will be over. Either one is dead, or one is bitten, or one should run away. Otherwise, compromise. That too is possible. I think she knows the dog's theory. Now, now listen. So the reactance that becomes unstable, take down when it is peaking at the peak. That is when its energy is very high, but are kinetically stable at ordinary temperature. That is also very important. Unstable, but stable, kinetically stable at ordinary temperatures, normal temperatures. Okay, so when these two girls are fighting each other at room temperature, okay, nothing will happen. Ah, you I moved. Keep quiet, keep quiet. Okay, finish. But the third girl, she will interfere and she will be prompting. Hey, she tells something about you, yeah, in your absence. That's all. So this is the temperature. At normal temperature, the fighting will be over. But in this case, when you increase the temperature, okay, what happens? So the fight will continue. So kinetically stable at normal temperature. Listen to this. Kinetically stable at normal temperature, but unstable at that particular barrier. Okay, right. Next. So this is called the thermodynamically unstable. So you can call this term as thermodynamically. Fourth point. When potential of the system undergoing reaction is plotted against the reaction coordinate, as I done here, reaction coordinate is nothing but that is this one. Reaction RC means reaction coordinator. It indicates what? The progress of the reaction. Please note down. X-axis is the progress of the reaction. With the progress of the reaction, the difference in potential energy between the reactants and the activated complex is activation energy. So you've got the potential energy here. Let me call it E1. And you've got the excited state energy, that is E2. This E2 minus E1 is called EA, that is activation energy. Are you able to follow? So what is the fourth point? That is delta E or EA is nothing but E2 minus E1. So what is E2? This is the reaction progress. This is the potential energy. So potential energy of the reactants, and it gets excited and takes product. So this difference. Okay. So let me call this one as E1 and this one as E2. So E2 minus E1 is called delta E, that is in this case EA, energy of activation. Do you understand this? Next, the reactants need to have the minimum energy to undergo the reaction through this transition state. So this is called a transition state. Transition state. What is transition state? It is a state at which the reactants attain the maximum energy, potential energy. Okay. So actually, this is also called the potential energy diagram. Then, so what is the fifth point? The fifth point is minimum energy to undergo the reaction. To undergo the reaction, and you should come across the transition state. So the transition state. It is usually represented as, for example, if you put R, and this can be called R asterisk. So transition state. So R to R asterisk. Energy excited level. So all these 4 points are very important with regard to activation energy. And this activation energy and catalysis is another important one. Activation energy and catalysis. Using catalyst, you can support the reaction. Let us draw the diagram. This is the reaction coordinate that is indicating the progress of the reaction along x-axis, and y-axis is the potential energy, PE, potential energy, or E. So the reactance, this is the reactant R, and it goes like this, get excited, and again comes down as a product, P. This is the energy of activation, that is the wave height, in absence of catalyst. Now, what you are doing is you are introducing some catalysts. Now, what happens by introducing the catalyst, the energy has come down like this so that they can effectively with the catalyst. You can put EA cat. Okay. So, what is activation energy? It is the activation energy in absence of catalysts. And the EA cat means activation energy reduced. Why? Because of the presence of catalysts. So the reaction rate can be increased. So it can quickly come across the barrier because you need not climb to such a height, The height, the wave height is less. So it can easily, these reactants can easily surpass the barrier. So the minimum amount of energy required to bring about the chemical reaction is called activation energy. And this activation energy can further be brought down by using the catalyst. So what is the role of catalyst to bring down the activation energy? Check it out. So catalyst important role is to bring down the activation energy. Of course, it occurs at the same temperature. That is the beauty of the catalyst, at same temperature. No need to raise the temperature. So that the reaction go faster. So you can increase the rate of the reaction. So this is regarding energy of activation and catalysis and collision theory. So we have come to the final part, collision theory. There is a term called collision frequency. As I already mentioned, how long these two dogs can fight each other, and how many times they can fight each other, and how many times they can collide with each other. So this is the number of collisions taking place. Here we talk about the molecules. So the number of collisions per second or per unit volume of the reaction. What is collision frequency? It is the number of collisions per second in a given time. That is per second per unit volume. per unit volume of the reaction mixture is called collision frequency. And this is represented by Z. This is represented by Z. Suppose let us consider two reactants A and B. Means you can put how many times these A and B collide with each other. ZAB. AB is AB, the reactants you can put. They collide with each other. So you can call it ZAB. How many times they can. And then you cannot take that is all the collisions fruitfully happening. So in that case, we have to find out the probability of collision also. So you have to introduce another factor that is called probability factor P. Take down. Probability factor. And e power minus EA by RT. It is the fraction of molecules with the energy. It is the fraction of molecules with the energy equal to or greater than EA. For example, whichever the fraction of let me say there are 1,000 molecules. Listen to me. There are 1,000 molecules. Only 800 are capable of causing out the energy value. I hope now you should be able to understand the fraction of molecules with energy equal to EA or above EA can be responsible for the reaction to occur. Okay. So E is greater than EA, either equal or greater than EA. Now the rate of the reaction is given by rate is equal to probability factor P ZAB. What is ZAB? Frequency factor, collision frequency factor into what is the fraction of molecules? E power minus EA by RT. Okay. So this is the rate of the reaction, the temperature dependence according to the collision rate.